things what you came for, not my speech. Hi everyone, welcome to Pharmacology of Antibiotic. Today we're going to cover up an interesting topic, the nucleic acid synthesis inhibitors. Let's start it.
First thing first, the antimicrobial drugs can be classified in a number of ways. These include by their chemical structures such beta-lactam or aminoglycoside. We can also classify them by sites of action, such as inhibitor nucleic acid functions or synthesis. Guess what? We will go with number 2, which is classification antibacterial agent by their site of actions.
What the antibacterial of nucleic acid inhibitor does? Basically, it's actually a drug that inhibits nucleic acid synthesis function by inhibiting the DNA polymerase and RNA helicase and RNA polymerase to block replication or transcription. I will introduce Georgie. Georgie will explain about types of antibiotic for this classification, mechanism of action, and its sites.
The antimicrobial agents that primarily target nucleic acid synthesis include metronidazole, quinolones, and rifamycins. Our first antibiotic, metronidazole, is a prodrug that requires reductive activation of its nitro group. Upon diffusing across the cell membrane of anaerobic bacteria, metronidazole is converted by the bacterial enzyme pyruvate ferredoxin oxidoreductase into nitro radical anion. This highly reactive radical is thought to be the main toxic agent that attacks DNA, causing strand breaks and mutations that lead to bacterial cell death. Now let's move on to quinolones. Unlike metronidazole, the mechanism of action of quinolones involves interactions with topoisomerases, which are the enzymes responsible for the unwinding and unlinking of DNA. Both DNA gyrase and topoisomerase 4 are the primary target of quinolones, which bind to these enzymes and effectively inhibit their function. This in turn blocks DNA synthesis and cell growth, ultimately leading to bacterial cell death. By combining with the protein of this bacterial DNA-dependent RNA polymerase, rifamycins bring all synthesis of RNA to a halt. Without RNA, the bacteria cannot make proteins that are essential for their survival, so the cell death eventually results.
Thanks, Georgie. We were well fed with useful information. Let's wrap up. You can refer to this link or website to know more details. We will see you in future. Bye.